Welcome to Psychology for Sleep. Let's rewire your mind for rest. Across the darkness of space, where light itself takes minutes, hours, even years to reach distant worlds, we find ourselves suspended in a cosmic ocean far grander than anything we can truly comprehend. Each point of light in the night sky is not just a destination, but a clock silently marking the distance between human curiosity and the great unknown. Tonight we will drift beyond Earth and journey across millions, even billions of miles, tracing the silent pathways through space and time. How long would it truly take to stand beneath Venus's golden clouds or witness the storms of Jupiter with your own eyes? What about Neptune, where a single day is longer than our imaginations dare to stretch? If you enjoy these journeys through time and wonder, please like this video and subscribe to help us travel even farther together. Now settle in. Let your imagination lift and let us drift gently outward into the waiting dark. Let's begin. Our journey begins not with motion, but with transformation. From earthbound to cosmic, from the moment ignition begins, the world we have always known starts to recede into the background of consciousness. The metal hull trembles, the force of millions of pounds of thrust pushes us upward. And in that ascent, we are no longer citizens of a planet. We are travelers of the void. As gravity loosens its grasp, Earth's familiar features, oceans, mountain ranges, swirling clouds, collapse into a single breathtaking view. It is here, in this narrowing perspective, that we experience the first shift in time. Second stretch, thoughts deepen. A profound stillness settles in our minds, as if the universe itself is taking a gentle breath before revealing its secrets. As the spacecraft crosses the Kármán line, the invisible boundary between Earth and space, everything changes. The pressure of the atmosphere vanishes. The sky, once a gradient of blues, transforms into velvet darkness. There is no sunrise, no sunset, only a slow turning of the planet beneath us. Every rotation, every shadow stretching across continents, becomes a reminder of how quickly life moves down below and how slowly time seems to drift up here. The hum of instruments replaces the sound of wind. Motion is now defined not by footsteps or wheels, but by orbit, by momentum, by gravitational pulls that extend far beyond anything we have felt on Earth. The journey ahead is not merely about distance. It is about shedding layers of everything human. The need for solid ground, the sense of up and down, the idea that time flows steadily forward. Here time becomes elastic. It stretches with each mile covered, each landmark passed. From low Earth orbit to the edge of the planet's gravitational influence, we begin to understand that space is not empty, but filled with invisible forces. Gravity pulls, light bends. Even time itself, like an ancient traveler, moves differently in these regions. As we complete our first orbit, Earth shines below us, serene and fragile. The cities that once seemed huge now appear as pinpricks of light scattered across the night side of the globe. The storms that once dominated our weather systems become slow spirals drifting across continents. From this vantage point, borders vanish, nations disappear. There is only one living world, turning patiently beneath the vastness of space, and with this realization comes the first hint of cosmic humility. Humanity has always been a spacefaring species. We have simply been waiting for the technology to remember. As our spacecraft aligns for transorbital injection, preparing to depart Earth's gravity well for the broader solar system, we feel the last tug of home. It is not just gravitational, it is emotional. The knowledge that every second moving forward will place greater distance between us and everything we have ever known. Yet, there is also peace in this moment. The peace of purpose, the piece of curiosity. Beyond Earth lies a celestial path carved over billions of years by the motions of planets and stars. We are not creating this journey. We are following it. With the engines firing once more, we are no longer orbiting Earth. We are leaving it. In this moment, our calendars no longer follow days, but distances. Our clocks no longer mark hours, but trajectories. And as the last glimmer of Earth's atmosphere fades into the eternal night, we finally understand. We have not lost our home. We carry it with us as a memory, a beacon, and a promise that every mile traveled is a step toward understanding not just where we are in the universe, but who we are. Our voyage has begun. Beyond the atmosphere lies a realm without resistance, where motion continues endlessly and gravity reshapes our path. Here, travel time is measured not in miles, but in velocity and slingshots, as planets themselves become stepping stones through time. In space, there are no highways like on Earth, no mapped-out roads or visible trails to follow. Instead, we are guided by forces older than time itself, gravity, momentum, and orbital geometry. These invisible currents form pathways that spacecraft must carefully navigate, using the subtle pull of planets to accelerate, redirect, and propel themselves forward. The true art of interplanetary travel is not brute force, but balance. We do not fight against gravity. We use it as an ally, allowing it to shape our journey like wind fills the sails of a ship crossing a cosmic ocean. These gravity pathways, called transfer orbits, follow precise mathematical arcs that connect one planet to the next. They are not chosen for convenience, but for efficiency. A spacecraft cannot simply fire its engines in a straight line through space. It must fall toward its destination, riding the curves in spacetime carved by planetary mass. Earth's gravity holds us in its embrace until we reach what scientists call escape velocity, about 11 km/s. Once this threshold is crossed, we are no longer bound to Earth. We become wanderers on the solar wind, carried not by fuel, but by the elegant physics of momentum. Here in the vacuum, motion is persistence. Without air resistance, every small push carries on forever unless interrupted by another force. A single burst of propulsion can send a spacecraft coasting for months or years. Every moment becomes a careful trade between time and energy. Go faster and you must use more fuel. Conserve fuel, and you must accept that time, days, weeks, years, will stretch into the great expanse ahead. The planets themselves become celestial rest stops along our journey. Their massive gravitational fields act as cosmic slingshots, accelerating our spacecraft without using a single drop of fuel. This technique, known as a gravity assist, is both a scientific marvel and a poetic dance. As we approach a planet, we fall into its gravity. As we swing past, we steal just a fraction of the planet's orbital momentum, using it to slingshot outward at higher speed. In exchange, the planet loses an immeasurably small amount of its own motion. Tiny but real, proving that even on an interplanetary scale, nothing in the universe is free. These invisible highways are not always open. They exist only in narrow windows of alignment, when two planets orbit into the correct positions relative to each other. Launch too early or too late, and the pathway closes. We would have to travel a longer, slower arc, wasting precious time. In space, timing is everything. Mission planners sometimes spend decades waiting for a perfect moment, a moment when Earth, Mars, Jupiter, and Saturn align like stepping stones stretched across cosmic waters. As we travel along these gravitational lanes, we are reminded that the universe is not empty. It is a web of forces, each pulling on the other, each shaping the future of everything in motion. Space is not a void to be crossed. It is a living landscape, constantly shifting, flowing, and guiding us through pathways that cannot be seen, only felt. And so we continue, eyes fixed, not on where we are, but on where gravity will take us next. The question isn't only how far Mercury is, but how slowly we can learn to arrive. From Earth's orbit, every instinct says, go faster. But the inner solar system teaches a subtler lesson. To reach Mercury, we must shed energy. Earth circles the sun at about 30 kilometers s. Mercury whips around it at roughly 47. As we drop sunward, our heliocentric speed naturally rises. So, the real challenge isn't getting to Mercury. It's arriving slow enough to stay. That is why missions to this small, scorched world use elaborate dances of flybys and gravity assists, shaving speed with each pass until capture becomes possible. The fastest way to simply touch Mercury is a direct transfer for a flyby, historically on the order of 3 to 5 months. Mariner 10 proved this in the 1970s, taking about 4 months from launch to its first Mercury encounter. But orbiting Mercury, truly lingering there, demands patience. NASA's Messenger spacecraft, launched in 2004, looped past Earth once, Venus twice, and Mercury 3 times, finally easing into orbit in 2011, about 1.2 years after departure. Europe and Japan's Bepi Colombo followed a similarly intricate path. 1 Earth flyby, 2 at Venus, then multiple at Mercury, spending years trimming speed before its planned orbital insertion. Inward is not closer. Inward is harder. Approach becomes an exercise in serenity. Each flyby is a metronome tick in a long composition, a precise brush with the planet's gravity, a quiet course correction, an incremental surrender of energy. Between encounters, the spacecraft coasts through radiant silence, the sun growing larger, harsher, more insistent. Thermal shields become lifelines. Sunlight here is up to 10 times stronger than what warms Earth. Guidance, navigation, and control systems practice a form of celestial Tai Chi. Small gestures, enormous consequences. And then Mercury fills the window. A charcoal gray world, cratered and ancient, framed by a solar glare so fierce it turns space to glass. Temperatures swing from searing to cryogenic, up to 430 to 800 degrees at noon, plunging below 170 degrees to 90 degrees at night. With almost no atmosphere, only a fragile exosphere of atoms knocked loose by sunlight and micrometeorites, there is no wind, no weather, no softening haze. Shadows carve knife-edged boundaries. The sky is always black. Time on Mercury feels inside out. A year lasts only 88 Earth days, yet one solar day from noon to noon takes 176 Earth days. Stand on the surface near the terminator, and you could watch the sun creep, hesitate, even seem to reverse near perihelion, a strange ballet born of orbital resonance and rotation. Here, dawn is a geological event. Scientifically, Mercury is a paradox wrapped in extremes. An outsized iron core, a global magnetic field in a world so small, a surface scarred by volcanic plains and tectonic cliffs, lobate scarps that reveal a planet still shrinking as it cools. Each orbit maps a chapter of planetary formation written in metal and light. How long does it take to reach Mercury? For a flyby, mere months. For an orbit, years. Patient years spent peeling away speed, layer by careful layer. The reward for that patience is a vantage point unlike any other in the solar system, the innermost keep of our star, where space, heat, and time are distilled to their elemental forms, and in that stark brilliance, Mercury offers a final lesson. Sometimes the shortest distance demands the longest grace. We've survived the furnace, a world where a day lasts longer than a year. But as we pull away, our journey takes us to our other neighbor, a planet cloaked not in stark darkness, but in a beautiful, suffocating light. Are we ready to face the crushing secrets of our sister world, the gilded cage called Venus? How long would it take to glide through its clouds and witness a sunrise that never ends? From the surface of Earth, Venus appears serene, soft, radiant, almost gentle in its beauty. Ancient astronomers named it after the goddess of love, enchanted by its steady brilliance. Yet behind that golden glow lies a planet so extreme that it challenges every expectation we have about habitability, atmospheric pressure, and time itself. To reach Venus, we must first understand that we are not simply traveling to a neighboring world. We are diving inward toward the furnace of the sun, falling toward a planet that spins to a different rhythm than any other in the solar system. Although Venus is Earth's closest planetary neighbor, reaching it is not as simple as pointing a spacecraft directly at it. Because Venus orbits closer to the Sun, we must first reduce our orbital speed around the Sun, essentially falling inward. This takes more energy than traveling outward to Mars. We must carefully time our launch to match Venus's orbital window, which opens roughly every 19 months. When the alignment is perfect, a spacecraft traveling on a Hohmann transfer orbit can reach Venus in about 120 to 150 days. Just 4 to 5 months of drifting across the void, watching the sun grow larger with each passing day. During the journey, the spacecraft is slowly captured by the sun's gravity, accelerating as it draws closer to the inner solar system. Temperatures rise, radiation levels increase, and our destination grows brighter, transforming from a distant star-like object to a world veiled in thick clouds that reflect nearly all sunlight back into space. This is why Venus shines so brilliantly. It is not a mirror, yet it reflects more light than any other planet, glowing like a cosmic beacon in the early morning and evening skies. Approaching Venus is like approaching a dream wrapped in mystery. There are no shadows here, only a constant blanket of light filtered through the atmosphere. The planet rotates so slowly, taking 243 Earth days to complete a single rotation, that a single Venusian day is longer than its year. If you stood on its surface, the sun would appear to rise in the west and set in the east, moving across the sky so slowly it would seem almost motionless. Imagine standing on a world where sunrise takes weeks, where time stretches so far that a single afternoon could last a month. Yet the beauty of Venus hides a punishing reality. Its atmosphere is composed almost entirely of carbon dioxide, trapping heat in an unstoppable greenhouse effect. The surface reaches temperatures of nearly 880 degrees, hot enough to melt lead. The pressure is over 90 times that of Earth, equivalent to being nearly a mile beneath the ocean. Clouds of sulfuric acid swirl overhead, reflecting sunlight back into space, even as they trap heat below. Once imagined as a lush jungle world, Venus is in truth a planetary cautionary tale. But while landing on Venus may be impossible for humans today, exploring its upper atmosphere could be our key to understanding planetary evolution. At about 50 kilometers above the surface, temperatures and pressures are remarkably Earth-like. It is here, in the golden haze, that future balloon-like habitats could drift peacefully above the inferno below, forever watching the horizon where sunset never truly ends. To reach Venus is not only to measure distance, it is to step into a mirror of Earth's past and a warning of its possible future. The journey there may take only months, but the revelations it offers could span centuries of human understanding. Though Venus is Earth's sister in size, Its atmosphere is a furnace of carbon dioxide. As we approach, we measure our journey not just in distance, but in the unfolding history of a planet that became a warning. Earth and Venus were born beside each other, sculpted from the same primordial dust that circled the infant sun. In their earliest days, they may have glimmered with oceans, clouds, and the building blocks of life. But where Earth calmed, cooled, and nurtured life, Venus spiraled into catastrophe. As we descend toward Venus, our spacecraft becomes a time machine, tracing the divergent paths of two planetary siblings, one that chose balance and one consumed by runaway transformation. The deeper we go, the more Venus reveals not just its nature, but the delicate fragility of habitability itself. From orbit, Venus looks peaceful, its creamy clouds slowly churning in a perpetual global blanket. Yet beneath that facade lies a world of relentless turmoil. The atmosphere is composed of over 96% carbon dioxide, with thick layers of sulfuric acid clouds that obscure the surface from view. The pressure is more than 90 times that of Earth, equivalent to being nearly a kilometer beneath the ocean. The heat reaches nearly 880 degrees, 470 degrees. On Venus, metal melts in the open air. Spacecraft survive only minutes before being crushed or cooked into silence. But Venus may not have always been this way. Some planetary scientists believe it once had oceans, shallow seas that evaporated as volcanic eruptions filled the atmosphere with greenhouse gases. Without a stable magnetic field to shield it from solar radiation, Venus slowly lost its water to space. Hydrogen escaped into the void while oxygen reacted with surface minerals, leaving behind a desert of superheated rock. Venus did not die in a sudden cataclysm. It transformed slowly, inevitably, over millions of years, proving that planets, like living creatures, can age and decay. The winds in Venus's upper atmosphere travel at hurricane speeds, circling the planet in just 4 Earth days. This phenomenon, known as superrotation, causes the clouds to race endlessly around the globe, driven by heat so intense that the very air seems to churn with desperation. Lightning flashes within the toxic storms. Acid rain forms in the clouds only to evaporate before it ever reaches the ground. Even the word rain loses meaning on Venus. What falls from the sky never touches the surface. As we simulate what a human explorer would experience, we find that a step onto Venus would be a step into a furnace. The skies would be an unbroken orange haze. The horizon would shimmer with refraction from the searing heat. There would be no blue sky, no stars, only darkness and the distant outline of volcanic plains. Venus is home to more volcanoes than any other planet, perhaps over 1,600 major ones, many still thought to be active. It is not merely hot. It is alive with internal fire, constantly reshaping its surface. Yet amidst this hostility lies a deeper truth. Venus is not just a failed planet. It is a mirror showing us what can happen when a delicate equilibrium breaks. The same greenhouse effect that warms Earth to life has gone unchecked here, turning paradise into purgatory. In studying Venus, scientists gain insight into Earth's future. Venus is not our enemy, it is our warning. If life ever flickered here, it is gone now, erased by the relentless embrace of heat and pressure. Venus is a reminder that habitability is not guaranteed, that a planet's fate is written not just in its composition, but in its delicate relationship with its star. The time it takes to reach Venus is measured in months, but the time it takes to understand it may span generations. As we depart its orbit, we do so with a sense of reverent caution, aware that in Venus we have glimpsed a possible destiny we must strive to avoid. We've seen our sister world, a paradise lost to fire. Now we turn our eyes outward, past our own blue home, to the red dot in the night sky. A world of rusted deserts and whispering dust that holds our greatest hopes. Are we ready to chase the dream of Mars? Mars beckons with its rusted deserts and whispering dust storms. Visible even to ancient eyes, the red planet holds our dreams of colonization. But how long until human boots leave the first footprints in its ancient sands? For centuries, Mars has called to us across the darkness. Its red glow a constant reminder that another world lies just within our reach. Unlike Venus, which cloaks itself in secrecy, Mars offers its surface plainly to the cosmos, inviting us to study its canyons, valleys, and frozen polar caps. It is not just a planet. It is a possibility, a world that might one day cradle human life beyond Earth. To journey to Mars is to journey into our own future, a future where life becomes interplanetary. But Mars is not an easy neighbor to visit. Its orbit around the Sun is elliptical, sometimes bringing it within 34 million miles of Earth, and at other times distancing it by more than 250 million miles. We cannot choose to leave whenever we want. Our departure must coincide with a cosmic rhythm known as the launch window, a moment that occurs roughly every 26 months when Earth and Mars align on the same side of the Sun. In this narrow corridor of opportunity, the journey is fastest and requires the least fuel, when conditions are ideal. A spacecraft traveling on a Hohmann transfer orbit can reach Mars in approximately 6 to 9 months. This is not a straight path, but an elegant curve through the solar system, using Earth's momentum to carry the spacecraft outward until Mars's gravity catches it. During this time, astronauts would spend more than half a year drifting through deep space, further from home than any human has ever traveled. Day by day, Earth would diminish into a pale blue star until it appears no brighter than Venus does from our skies. The psychological journey in many ways is greater than the physical one. For the first time in human history, travelers to Mars would watch Earth become just another point of light in the universe. Communications would be delayed by minutes. Time would take on a different meaning, not measured in days or schedules, but in distance from home. Each moment would be accompanied by the knowledge that returning is not immediate, that every mile forward is a mile deeper into the unknown. As the spacecraft approaches Mars, the planet gradually grows from a red dot into a glowing orb. Its rusted plains and ancient riverbeds reveal themselves through swirling dust storms. The thin atmosphere, less than 1% as dense as Earth's, provides almost no protection from the harsh radiation of the sun. Yet below that dusty veil lies a world that once flowed with water, where ancient oceans may have stretched across its surface, where life may have once taken root. To reach Mars is to stand at the threshold of two great questions. Could life exist beyond Earth? And could humans one day thrive here? Reaching Mars isn't a straight line. It is a dance of orbital alignment. In space travel, timing isn't just important, it's everything. As Earth and Mars race around the Sun at different speeds, the distance between them is constantly changing. There are moments when the two planets line up in just the right configuration, creating a kind of cosmic doorway. If a spacecraft is launched during this precise window, it can glide efficiently along a curved path called a Hohmann transfer orbit, using minimal fuel while still gaining the maximum gravitational assist from the Sun. But if we miss this opening, the door closes, and the opportunity vanishes for nearly 2 years. Think of Earth and Mars as two runners on separate tracks. Earth is on the inner lane moving faster. Mars is on the outer one moving slower. In order to intercept Mars, We must leave Earth at exactly the moment when Mars is just ahead of us in its orbit. If we leave too late, we'll arrive where Mars was, not where it is. The universe does not wait for us. Its motions are precise, predictable, and indifferent to our schedules. We must align ourselves with the clockwork of the cosmos. These launch windows are calculated years in advance, down to the minute. Mission designers simulate planetary positions with powerful computers, predicting where Earth and Mars will be not just months from now, but decades or even centuries into the future. A launch mistimed by even a few days can require thousands of extra pounds of fuel, slowing the craft or causing it to miss Mars entirely and drift endlessly through space. We've now mapped the journey to the Red Planet, a voyage defined by patience and precision. The first step onto Martian soil would not just mark the beginning of planetary exploration, it would signal the beginning of our evolution as a multiplanetary species. But before we can journey to the great giants of the outer solar system, we must first pass through a different kind of realm, a vast silent field of ancient stone, the ghosts of a planet that never was. Are we ready to cross the asteroid belt? Between Mars and Jupiter lies a realm of ancient stone. It is not the chaotic field of movies, but a sparse museum of planetary fragments. As we cross, we measure the time since the birth of the solar system itself. The asteroid belt stretches across hundreds of millions of miles, a vast ring of rocky remnants that once might have formed a planet. Instead, the immense gravitational pull of Jupiter prevented these fragments from ever coalescing into a world. Today they drift silently through space, relics from a time when our solar system was still forming, unfinished pieces of a cosmic puzzle. As we cross this region, the journey becomes less about reaching a destination and more about traveling back in time to witness the earliest building blocks of planets like Earth. Contrary to dramatic portrayals in science fiction, these asteroids are not clustered tightly together. Space between them is so vast that a spacecraft could pass through the belt without ever encountering a single rock. On average, objects within the asteroid belt are separated by hundreds of thousands of miles. In many ways, the greatest danger here is not collision, but isolation. The silence is profound. There is no air, no wind, no sound, only the distant glimmer of ancient stones rotating slowly in the blackness. Each one a witness to billions of years. As we travel deeper into this region, it becomes clear that the belt is not a graveyard. It is a library. Each asteroid is a page in the story of planetary evolution, preserving minerals, metals, and ice unchanged since the dawn of our solar system. Some are rich in water bound within their minerals, offering potential resources for future missions. Others contain rare metals in concentrations far greater than anything found on Earth. In the far future, humanity may look to this region for sustainable off-world mining, transforming these silent stones into stepping stones for interplanetary civilization. Time itself feels different here. There is no day or night, no rising or setting sun, only an unchanging panorama of stars. The only passage of time is the gradual shifting of the sun's light as our spacecraft continues its journey outward. In ancient times, the belt was a cradle of possibility. Now it is a quiet threshold, a boundary between the familiar inner planets and the vast, mysterious outer realms. We pass by Ceres, the largest object in the asteroid belt, once classified as a planet in its own right. At nearly 600 miles across, it is a dwarf planet with water ice beneath its crust and mysterious bright spots that reflect the light of the distant sun. Some scientists believe that beneath its surface could lie a hidden ocean, perhaps even the ingredients for life. Other asteroids, like Vesta, reveal signs of ancient volcanic activity, hinting at a time when these bodies were not cold and dormant, but alive with internal fire. Crossing the asteroid belt is a journey that takes months, even at immense speeds. Yet the true distance is not measured in miles, but in moments of reflection. These drifting stones remind us that we are part of a dynamic system, one that has evolved, collided, and transformed over eons. Earth and Mars, Venus and Mercury, these planets are complete chapters. The asteroid belt is an unfinished sentence, a celestial pause in the great story of our solar system. As we leave this region behind, we are no longer just travelers. We are historians of the cosmos, carrying with us the knowledge that every grain of dust here is older than life itself. Ahead of us lies the first of the great giants, a colossal king so massive it bends time around it. Are we prepared to enter the court of Jupiter? Jupiter looms in the darkness, a world so massive it bends time around it. A journey here stretches our imagination of distance. What would it truly feel like to approach a planet deeper than all the oceans of Earth combined? As we leave the asteroid belt behind, the clock of our journey begins to tick differently. Every mile now places us deeper into the dominion of Jupiter, the largest planet in our solar system, and the ancient guardian of our cosmic neighborhood. Its presence is unmistakable. Long before we see Jupiter with our eyes, we feel it in the instruments aboard the spacecraft. Gravity begins to shift. Space itself seems to curve toward an unseen colossus. This is no ordinary destination. This is a journey into the realm of giants. Reaching Jupiter is a monumental endeavor. Depending on the trajectory and technology used, a spacecraft can take anywhere from 13 months to nearly 6 years to arrive. For example, NASA's New Horizons probe, one of the fastest objects ever launched, reached Jupiter in just over a year. Meanwhile, other missions like Galileo and Juno took a longer route, using gravity assists from inner planets to gain the velocity needed for precise orbital insertion. But regardless of the path, the moment of arrival is unlike any other in solar exploration. The instant when Jupiter's immense gravitational force takes hold, pulling the spacecraft into its sphere of influence. Jupiter contains more than twice the mass of all the other planets combined. It is not just a world. It is a failed star, a celestial embryo that never accumulated enough mass to ignite nuclear fusion. As we approach, its swirling bands of red, orange, and gold begin to fill our view. Its storms, some larger than Earth, itself rotate with unending fury, fueled by internal heat left over from its formation. Here, gravity is not just a force, it is an experience. Time itself dilates slightly in Jupiter's presence. Seconds pass just a little differently, a subtle reminder that we are now under the influence of a planetary titan. In the darkness of space, Jupiter glows faintly from the heat rising within. Unlike Earth, which warms itself with sunlight, Jupiter radiates more energy than it receives, powered by the slow gravitational compression of its massive body. As we draw closer, we see that its clouds do not drift placidly. They churn, they spiral, they rise and fall in colossal waves, forming structures so vast they defy comprehension. The Great Red Spot, a storm that has raged for centuries, spins like a blood-red eye, watching the solar system unfold. The journey here is not just measured in distance, but in awe. Our perception of scale begins to dissolve. Jupiter's diameter is 11 times that of Earth. Its magnetic field is 20,000 times stronger. If we could hear electromagnetic waves as sound, Jupiter would roar with an ancient cosmic thunder echoing across the void. And yet, despite its immense mass, Jupiter has no solid surface. To reach its center is to journey through layers of gas, liquid hydrogen, metallic hydrogen, each layer more extreme than the last, until matter itself becomes something alien and unknown. Even as we approach the orbit of its moons, the journey continues. Europa, Ganymede, Io, and Callisto drift around Jupiter like miniature planets, each with their own secrets. Some are volcanic, some are icy. Some may harbor oceans beneath their crusts. Oceans that could cradle life in the dark. No spacecraft truly visits the outer planets without first dancing around Jupiter's orbit. Jupiter is not just a destination, it is a gateway. Its immense gravitational pull acts as a cosmic slingshot, capable of accelerating spacecraft to speeds that would otherwise be impossible with fuel alone. As we approach this planetary giant, we are not merely observers of its majesty, but participants in a celestial maneuver so elegant and powerful that it has enabled humanity to reach the farthest edges of our solar system. A gravity assist is one of the most ingenious strategies ever developed in space exploration. As a spacecraft approaches Jupiter, it falls into its gravity well, accelerating as it is pulled toward the planet. Instead of crashing, it arcs behind Jupiter, catching a fraction of the planet's forward momentum as it orbits the Sun. This exchange is subtle, imperceptible to Jupiter, but monumental to the spacecraft. With no fuel expended, the spacecraft is suddenly traveling faster, propelled outward on a new trajectory. This method was famously used by both Voyager 1 and Voyager 2. Launched in 1977, these spacecraft were designed to take advantage of a rare planetary alignment. By precisely timing their journey and using Jupiter's gravity, they gained enough speed to visit all 4 outer planets in a single mission. Without the slingshot effect, reaching Neptune alone would have taken more than 30 years. Gravity became a silent engine. As our spacecraft swings behind the planet, Jupiter fills half the sky, glowing with storms that have raged for centuries. In that moment, we are suspended between 2 forces, the pull of Jupiter and the forward motion of its orbit. Then, with silent precision, we are flung outward. Our speed multiplies, our path shifts. We draw closer to the great red spot, an unending storm larger than our entire world. As our spacecraft settles into orbit, we enter the presence of one of the most enduring wonders of the solar system. This colossal vortex has raged for at least 350 years, possibly far longer, swirling relentlessly within the planet's dense atmosphere. If Earth's fiercest hurricanes last days or weeks, the great red spot is their ancient ancestor, spinning across centuries. From our vantage point, high above Jupiter's cloud tops, the storm appears as an enormous oval colored in muted crimson and copper. Lightning flashes silently in the swirling clouds, some bolts so powerful they could ignite entire cities. Winds howl at speeds over 400 mph, and yet, in the stillness of space, we hear nothing. The storm is silent, its fury expressed only in motion. The great red spot is so large that 2 or even 3 Earths could fit inside it. Observations across decades have revealed that the storm is slowly contracting, becoming taller and more circular as it ages. Is the great red spot dying, or is it evolving? A storm that lasts centuries may be as fleeting as a raindrop in Jupiter's vast atmospheric cycle. To truly comprehend the great red spot, is to accept the vastness of planetary time. On Earth, we measure time by hours, days, and years. On Jupiter, we measure it by storms that span generations. We leave Jupiter's orbit with a new understanding. In the grand scale of the universe, even storms are not events. They are eras. We've used the giant's gravity as our engine, and now we are propelled even further into the cold and dark. Far ahead, a dream sculpted from ice and light begins to rise. Are we ready to witness the rings of Saturn? Farther still, Saturn rises like a dream sculpted from ice and light. Its rings stretch wider than Earth itself. Reaching this world tests the limits of time and human patience. As we leave the gravitational embrace of Jupiter, our spacecraft continues onward, journeying through a realm where sunlight is fading into a pale, distant glow. The darkness deepens, but ahead, something luminous begins to emerge. A delicate, shimmering halo suspended in space, Saturn, the jewel of the solar system, slowly reveals itself. Unlike any other planet, its beauty is immediate, undeniable, and otherworldly. The rings, made of countless shards of ice and rock, catch the faint light of the sun and scatter it in all directions, creating a cosmic crown that glitters like frozen fire. Reaching Saturn takes time. Years, not months. The fastest spacecraft ever sent to Saturn, NASA's Cassini, took nearly 7 years to arrive. Yet every day of travel is rewarded the moment Saturn comes into view. While Jupiter is massive and imposing, Saturn is graceful and enigmatic, a planet of golden hues. Wrapped in veils of methane clouds and encircled by rings that stretch up to 175,000 miles from edge to edge. Despite their grandeur, these rings are incredibly thin, no thicker than a few dozen feet in many places. A planet-sized masterpiece sculpted with the precision of a single brushstroke of cosmic art. Saturn is a world of paradoxes. Though it is the second largest planet in our solar system, it is the lightest by density. If there were an ocean large enough, Saturn would float upon it. Its winds howl across the atmosphere at speeds exceeding 1,100 km/h, faster than hurricanes on Earth. Yet the planet exudes a calm, ethereal presence, seemingly untouched by time. Saturn does not rage like Jupiter. It revolves in silence, its rings gently spinning like the slow hands of a celestial clock. Gliding into the orbit of Saturn's rings is like entering a cathedral carved of ice and light. There is no sound, no wind, no atmosphere to disturb the stillness. Each fragment, whether the size of a grain of dust or a mountain, floats in its own quiet rhythm, locked in a delicate balance between gravity and momentum. The rings spin in flawless harmony, each particle following a path set in motion billions of years ago. In this region, time is not measured in seconds or minutes, but in revolutions, each orbit a silent echo of ancient cosmic history. As our spacecraft glides above the rings, we see that they are not a single structure, but a vast collection of ringlets, some thin as ribbons, others wide as continents. Their composition is deceptively simple, ice and rock, but these frozen particles are more than frozen debris. They are remnants of a moon that never was, or perhaps the shattered remains of one that once orbited Saturn before being torn apart by gravity. Time stretches differently here. There is no sunrise or sunset within the rings, only an endless glow of refracted sunlight. If we were to reach out and touch one of these icy fragments, we would be touching a relic of primordial time. Some of these particles may be as old as the solar system itself, unchanged, untouched, drifting through ages while civilizations rise and fall billions of miles away on Earth. Saturn's moons add yet another layer of mystery. Titan rises through Saturn's hazy glow like a world imagined in a dream. Wrapped in a thick orange atmosphere, it is the only moon in our solar system with weather, rivers, rain, and lakes. But not of water. Here, methane flows as liquid. It rains methane from clouds. Lakes lap against icy shores in cycles that mirror the hydrological rhythms of Earth. Though on Titan, everything is slower, colder, and stranger. Standing on Titan is not like standing on any world we know. It is stepping into an echo of what early Earth may have looked like before life began. The time it takes to reach this world reflects its remoteness. Our journey to Titan begins with orbital capture around Saturn. From here, it takes weeks to carefully descend toward the moon's orbit. A spacecraft descending through its clouds would take hours to reach the surface, passing through layers of organic haze that scatter sunlight into a perpetual twilight. Here, a single day lasts the equivalent of 16 Earth days. Night is not a moment. It is an era. Beneath the haze, Saturn's rings are often hidden. But sometimes through breaks in the clouds, they appear as ghostly arcs in the sky, reminding us that this world is part of a much larger celestial symphony. Beneath Titan's frozen surface, scientists believe a vast subsurface ocean of salty water may exist, kept liquid by internal heat. This ocean could be one of the most promising environments for life beyond Earth. We've drifted through Saturn's frozen dream and stood on the shores of Titan's methane seas. Now the distances grow vast. Our spacecraft must enter a kind of hibernation as years pass in the silent drifting between orbits. Far ahead, a pale blue world, tilted like a fallen compass, awaits. Are we prepared for the long? Now the distances grow vast. Our spacecraft enters a kind of hibernation. As years pass in the silent drifting between orbits, Uranus awaits, a pale blue world, tilted like a fallen compass. Beyond Saturn, a profound stillness takes over. The sun shrinks to a distant lantern, its warmth too faint to sustain solar-powered systems alone. Here our journey becomes a test, not of speed, but of endurance. The path to Uranus is long, typically taking 7 to 10 years, even with gravity assists. During much of this time, a spacecraft moves silently, systems powered down to preserve energy, instruments entering sleep cycles. It is a voyage through deep time where days blur into months and months into years. Each moment becomes a gentle drift through the void. Our craft, a lone traveler in the cosmic dark, following a trajectory set in motion long ago. Uranus is unlike any other planet in our solar system. While most planets spin upright or slightly tilted, Uranus lies nearly on its side, its axis tipped by 98 degrees. This gives it the strangest seasons imaginable. Each pole spends 42 Earth years in continuous daylight, followed by 42 years of uninterrupted night. Imagine a world where winter lasts longer than a human lifetime, and sunrise comes but once every 4 decades. It is a planet of extremes, not in heat or storm, but in time itself. As our spacecraft approaches, its speed gradually decreases. The gravitational influence of Saturn fades behind us, and Uranus begins to assert its presence, a silent giant composed mostly of icy materials like water, ammonia, and methane. Unlike Jupiter and Saturn, which are gas giants, Uranus is classified as an ice giant. Its atmosphere is thinner, its layers denser, its composition more mysterious. The methane in its upper atmosphere absorbs red light, giving the planet its characteristic pale blue glow. A glow that seems to pulse softly in the darkness, like a sleeping world awaiting its next awakening. To reach Uranus requires not just distance, but precision. The planet orbits more than 1.8 billion miles from the Sun. Communications from Earth take nearly 3 hours to arrive. A single course correction could take days to verify. Navigation becomes less about active control and more about trust. Trust in the mathematics, in the gravitational models, in the subtle push of cosmic forces guiding the spacecraft forward. On Uranus, a single season can last 21 Earth years. We measure not only the time to arrive, but the time to see a sunrise across a planet where dawn itself moves slower than any human lifetime. Imagine standing on a world where the concept of morning and evening is stretched beyond comprehension. On Uranus, sunrise is not a moment, it is an era. Instead of a gentle transition across the sky, the sun crawls slowly upward, barely shifting in position over the span of decades. A single Uranian year lasts 84 Earth years. Spring, summer, autumn, winter. Each stretches the limits of human perception. If a child were born at the beginning of a Uranian spring, they would reach adulthood before summer arrived. As our spacecraft orbits high above the planet, we watch the sunlight pour across its pale blue atmosphere like a slow wave. The boundary between light and shadow, known as the terminator, barely moves. Day and night do not alternate in cycles of hours, but in ages. The slow rotation of Uranus combined with its extreme tilt means that one hemisphere lives under the constant gaze of the sun while the other is plunged into deep icy darkness. The moons of Uranus experience these extreme seasons as well. As they orbit the tilted planet, their surfaces pass in and out of sunlight over decades, triggering cycles of freezing and thawing that may affect subsurface oceans. Some moons, like Miranda, bear immense cliffs and ridges, evidence of geological upheavals that may be tied to these long cycles of warming and cooling. In this part of the solar system, time is not a simple measure. It is a force shaping the very surfaces of worlds. To understand Uranus is to step outside the boundaries of human time. It is to realize that our clocks and calendars are meaningless in the grand architecture of the cosmos. But our journey is not over. We must push even further toward the very edge of the gas giants, to a world of sapphire winds that howl faster than any storm on Earth. What secrets await us in the deep blue of Neptune? Beyond Neptune, the sun becomes a distant star. Its wind weakens, the journey slows. We now travel through a realm where time seems to stretch infinitely. Here, at the outer edge of our planetary system, we begin to leave behind the comforting breath of our star. For all of Earth's history, the sun has exhaled a continuous stream of charged particles, the solar wind, that flows outward in every direction, creating an invisible bubble known as the heliosphere. This protective cocoon has shielded our solar system from interstellar radiation, shaping the boundaries of our cosmic home. But now, as we push farther than Neptune's orbit, that bubble begins to thin. The solar wind loses strength. The influence of the sun's magnetic field diminishes, and with each passing mile, we step deeper into an ancient boundary zone where our star's dominion begins to fade. This region is known as the heliopause, the place where the solar wind collides with the interstellar medium, the sparse, cold fog of atoms and cosmic particles that fills the galaxy. Unlike the sharp borders of planets, this boundary is not a wall, but a gradual blur. Our spacecraft detects fewer and fewer solar particles. In their place, higher levels of galactic cosmic rays begin to appear. Radiation traveling from distant stars, supernovae, and cosmic events far beyond our solar system. Here, the sun is no longer the dominant presence. It is merely one star among billions. Time, too, begins to change in this place. With no gravitational wells to fall into, no orbital alignments to chase, our spacecraft coasts steadily into the great unknown. The journey becomes less a matter of arrival and more a meditation on endurance. It may take years, even decades, for a craft to cross this boundary. The distances are so vast that conventional terms lose meaning. Beyond the heliopause lies true interstellar space, a realm untouched by any planetary influence. Only two human-made objects, Voyager 1 and Voyager 2, have ever crossed this frontier. Their signals take more than 18 hours to reach Earth, yet they still speak faintly, their voices echoing across the darkness, reminding us that humanity has already extended a hand into the galaxy beyond. At the edge of the solar wind, we confront a profound truth. Our solar system is not a closed system, but part of a larger galactic ocean. We have touched the void, the very boundary of our sun's influence. But there is one last lonely sentinel waiting in the dark, a frozen relic of creation, once called a planet, that still calls to us. What will we find when we reach Pluto? Pluto is no longer classified as a planet, yet it still calls to us, a frozen relic of creation. Its journey is measured in decades. One spacecraft, one chance, one silent flyby. As we travel beyond Neptune's orbit into the dim outskirts of the solar system, we are drawn to a world once considered the ninth planet, a world of mystery and myth. Pluto, small and remote, drifts through the Kuiper Belt like a solitary wanderer caught between eras. It is not a planet in the modern sense, but it is not merely a rock either. It is a preserved chapter of the solar system's earliest history, orbiting the sun in a long, stretched ellipse that carries it farther from home than any other major body ever classified as a world. To reach Pluto is to reach a frontier of knowledge, a place where the known universe gives way to the unknown. The journey to Pluto is the longest interplanetary voyage humanity has ever attempted. New Horizons, the first and only spacecraft to visit Pluto, took 9 and 1+2 years to reach it, traveling at extraordinary speeds, crossing more than 3 billion miles. For nearly a decade, it coasted through darkness. A slumbering traveler, there is no second chance. Once the spacecraft approaches Pluto, it cannot slow down. It must capture every image, every measurement, every reading in a matter of hours before it is flung onward into the deeper void forever. As we draw near, Pluto slowly comes into focus, not as a dull, dead rock, but as a breathtakingly complex world with glaciers of nitrogen ice, mountains of frozen water, and a thin, trembling atmosphere. The largest heart-shaped glacier on its surface, known as Tombaugh Regio, reflects sunlight with dazzling brightness, hinting at active geological processes. Time here flows differently. A single year on Pluto lasts 248 Earth years. A human being could not live long enough to see it complete one full orbit around the Sun. Orbiting Pluto is its companion, Charon, a moon so large relative to Pluto that together they form a binary system, orbiting a point in space between them. And when our spacecraft performs its brief flyby, we are left with a sense of profound stillness. We cannot linger. Pluto slips past us in silence, and we are propelled onward into the Kuiper Belt, a vast region of icy bodies, comets, and dwarf planets yet to be explored. This is where the solar system ends and the mysteries of interstellar space begin. We've reached Pluto after a journey of nearly a decade, but to travel even further to the true outer worlds would take lifetimes. How could we possibly make such a voyage? What if the answer isn't to go faster, but to not experience time at all? What if we could sleep through the decades? To reach the outer worlds in a human lifetime, we must consider something once only science fiction, sleeping through the decades. What does time become if you are not awake to witness it? As our journeys extend further into the solar system, time itself becomes the greatest barrier. Even at extraordinary speeds, missions to the outer planets can take decades. For a spacecraft, decades are manageable, but for a human being, decades are lifetimes. A journey to Neptune or beyond Pluto is not merely a trip. It is a commitment to vanish from Earth's timeline. And so the question arises, could we one day sleep through time? Cryogenic travel, the slowing or suspension of biological processes through extreme cold, is a concept born in the pages of science fiction. The idea is simple in theory. A human is put into a deep, regulated sleep. Body functions are reduced to the barest minimum. Metabolism is slowed to a near halt. In this state, aging could be drastically reduced, perhaps nearly paused. Days, months, even years might pass like moments. If perfected, cryogenic sleep could turn a 30-year journey to the outer solar system into what feels like a single night. Imagine drifting through space in a cryo-sleep chamber. Outside your window, a distant planet glides silently across the stars. Inside, your heartbeat is slow. Your breathing shallow. Your body is suspended, held in a kind of biological stasis, waiting for the moment of reawakening. Space becomes a dream you do not experience in real time. This isn't just fantasy. Nature has already solved this problem. Frogs in polar regions freeze solid during winter, only to thaw and return to life in spring. But cryogenic travel is not merely a technical challenge. It is a psychological frontier. What happens to the human mind when time is erased? When memory becomes a bridge between centuries? Time in cryogenic travel becomes elastic. It ceases to be something we experience. It becomes something we cross. The outer solar system, once unreachable, becomes accessible not by increasing speed, but by surrendering to stillness. By sleeping through time, we redefine what it means to travel. The limits of a human lifetime dissolve. The universe opens. Sleeping allows us to conquer time, but it doesn't conquer distance. To truly explore, we need to go faster. But what happens when we approach the one speed limit the universe will not let us break? What is travel like at the speed of light? From Earth to the Kuiper Belt, each step reveals a truth. Planets are not just destinations, but moments in time. Our journey maps not just space, but history. As our spacecraft drifts through the outer reaches of the solar system, we begin to understand something profound. We did not simply travel outward. We traveled backward and forward through time. Each world we encountered served as a chapter in the cosmic story. Mercury, the scorched remnant of planetary formation. Venus, a cautionary tale of runaway transformation. Earth, a cradle of life and consciousness. Mars, a memory of what might have been. The giants, keepers of storms and gravity. The dwarfs, guardians of the outer frontier. What began as a journey through distance has become a journey through meaning. Perspective out here changes everything. Looking back toward the inner solar system, the planets form points of light indistinguishable from stars. Earth, our home, our everything, is now no larger than a shimmering pearl glinting in the cosmic sea. In that single glimmer lies every human memory, every conflict, every triumph, every word ever spoken. All of history contained in one fragile dot of light. This perspective is not humbling. It is awakening. It reminds us that the divisions we create on Earth are invisible from space. In seeing our smallness, we discover our significance, not in our size, but in our awareness. We are the universe contemplating itself. As we look beyond Pluto toward the vast Oort cloud, we ask one final question. If it takes decades to reach the edge of our own solar system, what would it take to reach another sun? At the far edges of our solar system lies a boundary that is not marked on any map. It is a threshold between what belongs to our sun and what belongs to the galaxy. Beyond Pluto stretches an enormous spherical shell of icy bodies, a silent reservoir of primordial material. To reach its outer edge would take a spacecraft tens of thousands of years. The idea of reaching another star becomes both tantalizing and daunting. The closest star system, Alpha Centauri, lies more than 4 light-years away. Traveling at the speed of our fastest spacecraft today, it would take over 75,000 years to reach it. Standing at this final horizon, we realize that our journey through the solar system has been more than a travelogue. It has been training, a rehearsal for the next great adventure. The edge of the solar system is not an ending. It is a beginning. As our journey comes to a gentle close, we find ourselves drifting in the serenity of the cosmic ocean. Our spacecraft silent, the stars shimmering like distant memories. What we discovered along the way is more than distance. It is perspective. Each planet we visited, from Venus's fire to Neptune's ice, made one truth shine brighter, that life, consciousness, and wonder are the rare jewels of the universe. As you breathe now, slowly and softly, let your thoughts drift like stardust. Feel the peace of knowing you are part of this grand cosmic story, not separate from the universe, but woven into it. The atoms in your body were forged in ancient stars. The rhythm of your heartbeat echoes the turning of planets. You are not merely in the cosmos. You are the cosmos, become aware of itself. We have touched the edge of the solar wind. We have seen the sun shrink to a distant star. And now, after a journey that has spanned decades and billions of miles, our craft begins the long fall homeward. The journey outward was one of discovery. The journey inward is one of remembrance. We spent our lives learning to leave our home, but what does it mean to return to it? And what do you do when you are the only one who has seen what lies beyond the sky? Our spacecraft, now a veteran of the deep void, turns. The engines fire, not with the desperate energy of escape, but with the patient, calculated thrust of return. For years our momentum carried us out, away from the light. Now gravity, that great invisible river, begins to pull us back, guiding us gently toward the furnace of the inner solar system. The first thing you notice is the change in light. For so long we lived in a perpetual twilight, a darkness punctuated by the cold, reflected glitter of ice giants and frozen moons. The sun was a single brilliant star, the brightest in the sky, but it was not a sun. It was not a presence. Now, with every passing week, it grows. It reclaims its territory. The pale pinprick becomes a disk, then a coin, then a blinding furnace. The warmth on the hull is no longer a faint memory, but a physical reality. After the profound, perfect cold of the Kuiper Belt, the heat feels like an echo of life itself. We fall past the great sentinels we once so eagerly sought. Neptune, the sapphire storm, is now a shrinking crescent in our sensors, its howling winds once again a silent mystery. Uranus, the tilted world, rolls by like a forgotten compass. Saturn, the jewel of the night, is a shimmering memory, its rings closing like a fan. And then Jupiter. We do not use it for a slingshot this time. We fall past it, a humble traveler in the court of the king. Its immense gravity tugs at us, a final firm handshake from the guardian of the outer realms. Its storms still rage, its eye still watches, as eternal and indifferent as the day we arrived. As we cross the asteroid belt, the ghost of a planet, it feels different. It is no longer a threshold to the unknown, but a gateway to the familiar. The inner solar system welcomes us. Mars, the red dream, feels like a neighbor. We see its rusted plains and know that, while we were gone, robotic emissaries have continued its work, and perhaps human footsteps are not far behind. Then we see them, two lights shining together, one the golden-shrouded mystery of Venus, the other The other is a piercing blue-white. It is a light that no other world possesses. It is not the white of ice or the gold of gas. It is the blue of water, Earth. After a lifetime spent staring at worlds of stone, gas, and ice, the sight of our home is an overwhelming physical shock. It is not quiet. It is not serene. It is a riot of chaotic, beautiful, living color. The impossible white of clouds swirls over the impossible, deep blue of oceans. The greens and browns of continents are a testament to something that we have found nowhere else. A surface in constant transformation by life, the silence of space. A sound I had come to accept as the natural state of the universe feels wrong. I find myself listening for the things I have not heard in decades. Wind, rain, the crash of a wave, a voice as our capsule separates and begins its fiery descent. The feeling is not one of arrival, but of impact. The first shiver of atmospheric resistance is a shock. The universe is touching us again. The silent drift is over. We are plunged into a world of friction, sound, and force. The orange glow outside the viewport is terrifying and beautiful. We are a meteor, a falling star, returning to the world that birthed us, and then the parachutes deploy. The sudden violent deceleration is a reminder of Earth's pull. We are home. To step out of the capsule is to be reborn. The air is the first miracle. It has weight, texture, and scent. The feeling of wind on the skin, after years in a sealed environment, is an intimacy you cannot prepare for. And the light, the sunlight filtered through a blue sky, scattering and making the world bright. It is so different from the harsh, direct light of the void. But the return is not an end. In some ways, it is the most difficult part of the journey. You have returned, but you are not the same. You carry the ghosts of other worlds within you. When you look at the moon, you see a waypoint, not a mystery. When you look at the stars, you see destinations. You have stood on the shores of Titan's methane seas. You have drifted through the silent snow of Enceladus. You have watched a storm rage for centuries on Jupiter and seen the sun rise over a planet where a season lasts a human lifetime. How do you explain this to a world that measures time in days and weeks? The truth of our journey is this. We did not go out to conquer the solar system. We went out to find our place within it. We are not a species meant for one world, but our home world is the only one of its kind we have ever found. It is the cradle, the exception, the pale blue dream in an ocean of magnificent silent reality. The journey has ended. We are home. But the cosmic perspective, once gained, can never be lost. We have returned from the void, but we have brought the void with us. It lives in our eyes, in our memories, and in the profound, unshakable knowledge that we are, and have always been, travelers. The stars are not above us. They are within us, and the journey, in truth, has only just begun. The journey is over. The capsule is a museum piece. The body has reacclimatized to the familiar comforting pull of 1G, and the ears have grown accustomed to the sounds of wind and water. I am home, but home is not the same because I am not. How does a story end when the experience it describes has no end? You live your life. You walk through city streets. You feel the rain. You talk to friends. But you carry a silent second awareness. When you look at the sun, you see not just a light, but an engine, a furnace you have flown so close to that you felt its heat radiate through a vacuum. When you look at the night sky, you do not see stars. You see places, you see the pale, steady light of Jupiter, and remember the violence of its storms. You see the faint glint of Saturn, and remember the impossible, silent perfection of its rings. The sky is no longer a ceiling. It is a map of my memories. The return was not an end. It was the beginning of the most difficult part of the mission, to make the rest of humanity feel what I felt, to translate the crushing silence of the void and the overwhelming, chaotic beauty of our living world into a language everyone could understand. The data was downloaded, the samples were analyzed, the images were broadcast. But data is not feeling. I became a storyteller. I spoke not of velocities or orbital mechanics, but of the feeling of time stretching into an era on Uranus, where a single season outlasts a human life. The feeling of the long sleep drifting through the dark for years, suspended between worlds. And most of all, the feeling of the return, that moment of fiery impact with the atmosphere, and the overwhelming, shocking blue of the ocean. At first, the world listened as if to a fantasy. It was a grand adventure, a spectacle. But then, slowly, the perspective began to take root. The images of Earth, that pale blue dream, taken from the edge of our sun's influence, did what no speech or statistic ever could. It showed our home as it truly is, a single, fragile living oasis in an endless, magnificent, and utterly indifferent desert. The true legacy of our journey was not that we had reached Pluto, but that we had, for the first time, truly seen Earth, and with that new sight, the world began to wake up. The question of how long it would take changed. It was no longer a matter of curiosity, but a matter of engineering. The solar system was no longer a collection of myths. It was a resource, a frontier, and a future. The red dream of Mars became a global project. The timelines were no longer measured in centuries, but in decades. The journey, once a 9-month ordeal, was now a calculated problem to be solved with new engines, perhaps the fusion drives we once only dreamed of. The goal was no longer just to visit, but to stay, to build the first outposts, to sink drills into the ice, and to one day, perhaps, light up a second world from within, the moons of the outer giants. Once the domain of science fiction became the focus of intense study. Titan, with its methane lakes, and Enceladus, with its hidden ocean, were not just destinations. They were possibilities. We realized that life might not be as rare as we thought, just hidden in places we never dared to look. The long sleep of cryogenic technology, the fantasy from Chapter 12, became the most urgent research of a new generation. We were no longer content to send machines. We had to send ourselves. But the most profound change happened here, on the waking world. Seeing our home from the void, a single living speck changed our priorities. The borders that had seemed so permanent, the conflicts that had seemed so important, all felt like arguments in a lifeboat. We had seen the outside. We knew how precious the inside was. Our journey did not just open up the solar system. It unified the Earth. We began to act as a single species with a shared destiny and a shared home to protect. The journey across billions of miles had in the end been a journey of a few inches, from the head to the heart. It taught us that our greatest technology was not our engines, but our consciousness. I am old now. My journeys are over. I walk on a beach with my granddaughter, a child of this new woken world. She has never known a time when humanity was confined to one planet. For her, Mars is a place people go. She points up at the twilight sky, just as the first stars are appearing. "Grandpa," she says, her voice small against the sound of the waves. "Which one was yours?" I look up. I no longer see the distant abstract lights I saw as a child. I see the map. I see the memories. I point to a faint, steady light rising in the east. "That one," I say. "The one that looks like a king." "That is Jupiter." She watches it for a long time, the wind blowing her hair. I wait for her to ask the old question. I wait for her to ask, "How long did it take?" But she doesn't. She turns to me, her eyes bright with a new kind of light. "How long?" she asks. "Until we can go together?" I smile. The journey has not ended. It is just beginning. We are no longer a species of one world. We are the children of the cosmos, and for the first time, we are truly awake.